Hello everyone, greetings from VNR JYOTHI Institute of Engineering and Technology. This is Manohar Reddy, Department of Cybersecurity, Data Science and AIDS. Today in this session I am going to explain you about the concept of generation and analyzation of broadcast tree. Generation and analyzation of broadcast tree. So in this, first of all, what is meant by broadcast tree? Broadcast tree is designed for the number of nodes in the network. So the number of nodes are going to represent in the form of tree. The broadcast tree supplies the message, delivering the message to all the nodes. So broadcast tree is a tree structure. It is used to deliver a message from one source node to all other nodes. So in the network, number of nodes are presented. So from the starting node to ending nodes, from the starting node to ending node, each and every node has to receive that message. So who is the sender, who is the source? The source node is delivering the message and the receiver node receives the message. So here the broadcast tree is a tree structure which forms like a tree structure used to deliver a message from one source node to all other nodes in a network. See this example. If we see this example, A, B, C, D, E, F, all are nodes. These are all called as nodes. So from the A node, we are going to transfer the message, sending the message to all the nodes, to all the B node, C node, D node, E node, F node. So without repeatedly the sending the same message along with the unnecessary paths, so we need to send the message to all the nodes, and that does not having the unnecessary paths, and that does not having the loop or cycle, so that the broadcasting is nothing but sending all the messages to all the nodes. So if you want to send one message to only one node, that is unicast. If you want to send one message to all other nodes, it is a multicast. And if you want to send, it is also called as broadcast. So if A wants to broadcast a message, to the B, C, D, E, F, these are all called as nodes. And if you want to send the message to all these nodes, the direction is what? Like this. A to B is a direct connection. So directly it is delivering the messages. Then next, A to C also direct messages. So direct connection, dedicated path, so that they can able to directly send message to the B and C nodes from the A node. Now coming to the D node, E node, F node, A does not send directly message to the D, E, F nodes. So that in that case, the A forward the message to the B and C. Now B is taking the responsibility to transfer that message to the D and E. So because of that, B transfer the message to the D, and similarly B transfer the message to E also, because D and E are under the B, right? So now B is broadcasting that message to the D and E. Similarly, C is under the A and F is under the C. So C is broadcasting the message to F. So every node receives the message and there are no loops. As we see this diagram, there are no cycles and there are no loops also. So each and every message is directly transferred, directly broadcasted to all other nodes. A broadcasted the message to the B and C, and B broadcasting that message to the D and E, C broadcasting the message to the E, F. So now all the nodes are receiving that message. All the nodes are receiving that messages. And what is meant by subnet? A subnet or subnetwork is a small logical network created by dividing a larger IP network into smaller parts. Creating a larger IP network into smaller parts. So suppose take an example, 192.168.1.0 or 24. It can be divided into smaller subnets. It can be divided into smaller subnets like 192.168.1.1, 2, 3, 4, like that up to 24. It can be divided into smaller subnet. That /24 means that the first 24 bits are representing the network portion. So x triple x dot triple x dot triple x dot triple x, that each and every portion is called as octet, and the first 3 octets are representing the 24 bits. First 3 octets are representing 24 bits. The subnet mask is 255.255.255.0 because It represents the first 24 bits or the network portion. Now for that network portion, the subnet mask is what? 255.255.255. The usable host addresses are 192.168.1.1 to 1.254. So that means you can host the addresses in between 1.1 to 1.254. 1.254. In between them, you can use any of the host address. For small example, assume we have these 5 devices. So A is the device, B device, C device, D device, E device. These are all nodes, and these all the nodes are contain the IP addresses like what? 192.168.1.1, 1.2, 1.3, 1.4 and 1.5. Now these all addresses are broadcasting that message from the source node to destination node. Suppose A is the source node, and B and C are the destination nodes, and for the B, D and E are the destination nodes. If we take an example like this, so A is broadcasting the message to B as well as C. Now B is broadcasting the message to D and E. So this is the way broadcasting the message from source node to ending nodes without repeating the loop, as well as without forming the cycle. So that is what we can do is in the subnetwork. And how to build that network topology? So assume the connections are, if you want to build the network topology for A to F nodes, now we need to take the actions. What one is what? There is no repetition of the path, there is no repeating the path, as well as there is no formation of the cycle, but we need to broadcasting the message to all the nodes. So assume the connections. A is broadcasting the message to B as well as C. Now B is broadcasting the message to D and E. Similarly, C is broadcasting the message to F. So let's here use only 5 nodes for example. If I take an example 5 nodes, so from these 5 nodes we reducing this F node from the C. Now the A is broadcasting the message to B as well as C, and B is broadcasting the message to D and E. So what are the connections? The connections are depending upon the number of nodes. So number of nodes, if number of nodes are 5, then number of connections are what? N minus 1, that is 4. N minus 1 is nothing but 5 minus 1, that is 4. So 4 connections are required to broadcasting the message from each and every node, that is with the 5 nodes. So if you want to broadcast any message in these 5 nodes, take an example as a source node as A, and remaining all the other 4 nodes are receiving the message with the 4 connections only, So see here in this diagram, A to B is one connection, A to C is one other connection. So 2 connections are there. And similarly from the B to D and B to E, 2 more connections. So total 4 connections are required. So A to B is one connection, A to C is one connection, B to D is another connection, B to E is also another connection. So total the number of connections are required to broadcasting all the message to all the nodes is depending upon the number of nodes. So number of nodes equal to 5, then connections are 4. If number of nodes are 6, then connections are 5 only. So the thing is what we need to remember, that no cycle is formed and no repetition path is allowed. So here select the broadcast source. Suppose A is the source. The objective is what? Send a packet from A to every other node. So initially, whenever it is broadcasting the message to all other nodes, it must be visited each and every node. So initially, it wants to send, the A wants to send a message to A, so then visited A. That means A is visited to itself and it is forwarding the packet to itself. So visited equals to A. And unvisited nodes are what? Remaining B, C, D, E are unvisited node. Now start the broadcast. So A sends the message to its directly connected nodes A to B and A to C. So broadcastly connected and forwarded the message to them. So A to B is 1, A to C is 1. So now A is visiting the both B and C. Now visiting is completed and broadcasting is completed. Now visited number of nodes are what? A, B, C. So 3 nodes are visited and the 3 nodes broadcasting is over. Now continue this broadcasting till remaining the nodes are visited. So node B now forward the message to its unvisited neighbors, like B is connected to A, D, E, right? B is connected to A, B is connected to A and D and E. So now A is already visited, so A is over. Now B wants to visiting the B, D as well as E. So A has already received the message, so B forward it's to B to D, B to E. Now all nodes have received the broadcast. Now all nodes are receiving the broadcast. So C is also visited. The resulting broadcasting tree is what? A to B, A to C. So A to B is 1, A to C is 1. That means A comma B comma C are visited. So visited of A comma B comma C. Now remaining next B, from the B to D, B to D as well as B to E also visited. So B to D and B to E also visited. So now total 5 nodes are visited. Total 5 nodes are visited. Now the tree edges are A to B is one edge, A to C is also on another one edge, and B to D is also another edge, and B to E also another edge. So total number of tree edges are 4. That is already we discussed in the previous slide. So the number of nodes equal to 5. The number of tree edges is n minus 1, that is 4. Therefore 4 edges are sufficient to reach all 5 nodes. So like the way broadcasting the message will happen in the network. So broadcast tree using BFS. So a common method for generating broadcast tree. So in what method we are using this generating the broadcast tree is what? BFS. So breadth first search. So initially it starts with the A node. Initially it starts with the starting node, that is A node. Visit it next, visiting the neighbor nodes. It must be visit the neighbor nodes, that is the B and C are the neighbor nodes of A. So now A must be visiting the both B and C. Now visit B's unvisited neighbors. Now A is visiting the B and A is visiting the C. Now B is visiting the unvisited neighbors. What are those? From the B, D and E are not visited nodes. So now the B is visiting the both D and E. So now after visiting the D and E, all nodes are now visited. All nodes are now visited. Therefore, the BFS broadcast tree is like what? This one. So A to B as well as A to C. Now from the B to D, B to E, because these two are visited nodes for B and these two are visited nodes for A. So now all nodes are visited while broadcasting the message from source to destination or starting node to ending node. So the broadcast process is what? Like this. The actual message propagation is what? Round 0. That means starting round. Round 0 is what? A. Only A has the message and A is broadcasting the message to itself only. So that is round 0. The next second round, that is round 1. A is broadcasting the message to B and C because B and C are directly connected. So now A broadcasting the message to B and C, that is the round 1. So this is what? Round 0. Itself it is directly messaging, and now B and C are round 1. So A is visiting both B and C. Now A, B, C have the messages. Next in the round 2, the B is visiting the D and E. B is visiting the B, D and U. So that is the round 2. So in the round 2, B visiting the D and E. Now A, B, C, D all nodes have the receiving the messages. All nodes have received the messages. So the broadcast completed in 2 levels or 2 hops from the source. This is the source and this is the ending. So from these two here, it completed 2 rounds. Round 0, round 1, round 2. 3 rounds it has completed to reach the broadcasting, to forward the broadcasting from source to destination. So analyze the broadcast trees. How to analyze the broadcast trees? So after structuring the broadcast tree, we can analyze the several properties. What are those properties? The number of nodes in the broadcast tree is what? 5 nodes. And the number of edges in the broadcast tree is what? the formula is what? Edges equals to nodes minus 1. That means the edges are depending upon the number of nodes that are presented. Edges are representing the number of nodes based on the number of nodes in the presented. So number of nodes are what? 5 minus 1, that is 4 edges. Out of all, that root node is what? A. Root node is what? A. And the leaf nodes are what? Nodes with no childrens. Nodes with no children. That means nodes without children. Nodes without children. How many nodes are there? C, D, E. These 3 nodes are without children nodes. Without children nodes. So because of that, we can call them as leaf nodes. We can call them as leaf nodes. And maximum depth. So maximum depth is nothing but height, longest path from the source to the ending point. So the longest path from A to E is A to B, B to D, or A to B, B to E. Because A to C is only 1 round, but A to B, B to D is what? 2 rounds, right? So therefore, maximum depth of this nodes are what? 2. Maximum depth of nodes are what? 2. See here example with the subnet addresses. So how we are broadcasting that from each and every system. The subnet is what? 192.168.1.0 to 24 systems. So how these 0 to 24 systems are broadcasting to each other. So now first system A is having 1.1, that is 192.168.1.1 is the starting address, starting node, starting tree. From this we can forwarding the 24 nodes, we can forwarding the message, broadcasting the message to 24 systems. So 1 to 1 to 1 to 2 and 1.1 to 1.3. So take an example in the previous scenario. If we have 5 nodes, if we have 5 systems, we are forwarding the message like this. A to B and A to C is one way, and the next B to D, B to E is another way. So the broadcast sources are from 1 to 1 to 1 to 5. That means 1.1 to 1.5 systems. So total 5 nodes are there. So we are representing the broadcasting address from 1.1 to 1.5. The broadcast sequence is what? Like this: 1.1 to 1.2, 1.3. From this 1.2, 1.4, 1.5 are the visiting nodes of this 1.2. So therefore, for 5 nodes, the visiting nodes are what? Like this: 1.1 to 1.2 is visited, 1.1 to 1.3 is visited, the next 1.2 to 1.4 is visited, and 1.2 to 1.5 is also visited. So in the laboratory or in the campus area, the broadcasting of the message from each and every system from the local area network or different area networks, we can broadcasting the messages from 1 to number of nodes. Depending upon the number of nodes, it requires the connections. So that is about the broadcasting of the generation and analyzation of broadcasting. So how the number of systems are broadcasting the messages from source to destination, how a number of nodes are broadcasting their information from source to destination. I hope all of you understand. Thank you.